Absolutely.
Yeah.
It is a good thing.
Right.
Good morning, everybody. Thanks for joining this webinar. With a new quote of this day, we are going to start this seminar. Never stop learning. Life never stop teaching. This pandemic has taught us hygienic. Learning is not enough. Sharing our knowledge to all is mandatory. We IPI is proud to be part of educating all with the latest technology and innovative project. With this quote, we like to begin our webinar. I like to invite Mr. Mahadev.
Good morning. Are you hearing?
Yes.
Yes.
Good morning. Good morning, friends. My heartiest welcome to you all and the managing committee members. It is a great pleasure to meet you all through this forum for the webinar on melt-blown PPE for PPE. I believe this right time to explore the subject and hope it would be useful topic too. For the current situation, this is the only way to meet delegates and share knowledge. Our IPI Chennai chapter is intended to do the service to the industry. We will do it for you with your support. Hope you will support us. I would like to welcome our speaker, Mr. Yark, Technical Head of Kingfa Science and Technology India Limited. With your permission, I invite Mr. Balaji, Joint Secretary of Chennai chapter, to introduce today's speaker. Welcome, Mr. Balaji.
Good morning, all. Good morning to all the participant, guests, IPA members, and all the people. Today's lecture is about the melt-blown PPE for PPE. As Mr. Nandakumar rightly said, the need of the hour is hygienics. For the hygienics, today, we are mandated to go out of our house with the mask on our face, which has become essential today. And many people are still not able to understand exactly the function of the PPE mask as it is, the different kinds of mask, and what are all the different parts going into the mask, the performance or the function of each of the layers coming into the mask. People talk of 4-layer, 5-layer, but what is it? So today's lecture attempts to explain some of the basics for the mask and the ingredients. Again, plastics comes to the help of the society. The melt-blown PP is a layer that comes in the mask, which gives a filtration against the virus and bacteria. Our speaker, Mr. Yark, has been part of Kingfa for the past 13 years. He is a postgraduate in plastic science and technology. He started getting into the R&D way back in 2012. Then he moved into the carbon fiber composites development. He is a person responsible for developing long glass fiber composites as well as long carbon fiber composites for Kingfa. 6 months back, he was deputed to be the head of the technical for Kingfa India, and his main outlook is to localize all the engineering plastics grade within India and introduce the long glass fiber composites in India also. In today's lecture, he will attempt to talk about the importance of the melt-blown PP, how melt-blown PP can be converted into the useful filtering layer in PPE, and what are all the issues associated in the manufacturer, and some insights on troubleshooting the manufacturer at the melt-blown PP fabric stage. Over to Mr. Yark.
Okay, thank you, Mr. Balaj.
Thank you.
Okay, thank you all. First, I would like to thank IPI to give me the chances to give the presentation for all of you. So it's my honor to be here. But this time is the webinar. I wish maybe soon I will come back to India, and then we can discuss, we can have a seminar, and then we can discuss face by face. Okay. First, I would like to share my experience about the coronavirus in China. On 22nd January, I can come back from India to China. Here is a photo. I arrived at the Guangzhou airport. I see everyone, most of everyone is wear a mask. About half an hour later, our government announced the lockdown in Wuhan city. And about after 1 day, the lockdown for the whole province, and later the whole China is locked down. So we have to stay at home to protect ourselves from the coronavirus. Fortunately, after about 2 months, the lockdown was lifted in Wuhan. We saw the coronavirus is stopped spread in our country. So I think in this presentation, I will share some experience of what we have done and what we should do to stop the pandemic of coronavirus. To stop this virus, the most useful or effective way is by the vaccine. Unfortunately, we're waiting for the vaccine to use in widely, but now we're still waiting. Maybe in the end of this year or next year, we will have this. But before that, what we can do? So I think first we need to lock down. But if we lock down, the economic will stop. We don't have a job. So this is also a big problem. The second, we need to wear some personal protective equipment, such like a mask. So in this presentation, I will focus on the mask and how we can protect ourselves. Besides, we need to keep some social distance, and also we should to isolation, confirm the patient and some contact. So this is what we can do to prevent the virus. This is my presentation. They have 4 parts. At first, I would like to introduce how to protect our from the virus. The virus can spread very easily from in the air. So when we're talking, or when we're sneezing, there are many droplets from our mouth or nose. They can travel to about more than 150 feet. This depends on different size. The small size can travel a little far than the larger particles. So if we don't have any protective, then our human is very easily to be infected by this droplet, because in this droplet there are many viruses. So we need to we need to wear the mask to protect ourselves, and we also need to wear the mask to protect others. We can have this photo. This person wear a mask with valves. This mask, they can protect only himself. They cannot protect others. So that's why we need to wear the right mask to stop the propagation of the virus. the mask we can divide it to two types. One type is for civil. This is for industrial use. Another is for surgical or medical use. So in different countries, they have different levels of mask, such like N95. It means 95 means the level of filtration. They can prevent the particles, some droplet or some under the virus to come into our mouth or our nose. Then they can protect ourselves. So if we choose the mask, we need to understand what this means and why it can protect ourselves. Here, I share a figure about the particle size and the PFE of each mask. So first, we need to understand the size of the droplet. Most of droplet or bacterial, the size is 0.7 to 2 micron. So this is some big droplet. But if the droplet is droplet nuclei, the size is 0.2 to 0.4 micron. So we should prevent this kind of particle to come into our mouth. So we have different kind of mask. First is the gauze mask. In my hand, this is a gauze mask. The PFE is very low. It's only less than 20%. That means most of the virus will come through this mask and into our mouth. So this is not effective. Then it's come to some cotton mask. The cotton mask is also not very useful. Then we need to choose some medical mask or surgical mask. In my hand, this is a medical mask. This mask can prove the PFE is about 80%. So that means 80% of particle can be prevented by this mask. And then we also have some this folded N95 mask or K95 or FFP2. So this mask is more useful because the particle filtration efficiency is above 95%. Most of these particles cannot come into the mouth. So some people will ask why this kind of mask can protect ourselves, but why some mask is not useful. So we need to come to take a look at the structure. If we have this mask, we can cut it into, we can cut this mask and then we can find what it is inside the mask. This is a 3-ply mask. So after I cutted this mask, we can find there's 3 plies. The outer layer is a spun-bound fabric, and in the middle layer is a metal-blown fabric. So this middle layer can protect ourselves from the virus. So here is some compare about these 2 fabric. The spun-bound is very strong, and it's not very easy to break. They have a good strength, but the filtration effect is not good. And the metal-blown fabric, the fiber diameter is only 2 to 5% micron. And the filtration effect is very good, but it's very easy to break. So we put in the middle layer. And so if we have this mask, the metal-blown fabric can prevent can capture the virus and protect ourselves. And if we check the 5-ply, the structure is similar. We have a 2 metal-blown fabric in this mask. That means they can capture more particles, more virus. So that this N95 mask can protect ourselves effectively. So if we take a look at the microstructure of the metal-blown fabric, this is the microstructure. We can find the fiber is very thin. The diameter is about 25 microns. And so they can stop some big particles. And around the fiber, on the surface, they have some electrical static. So they can capture some particles by the static electricity. So by this 3 factor, the fiber diameter, the evenly distribution, and the static electricity, then this metal-blown fabric can capture the virus. Then we can meet the standard of each requirement from the NIOSH, from the CE certification. Then we can meet the bacterial filtration efficiency or the particle filtration efficiency. So this is why the mask have this effect to capture the virus. In this slide, it shows different kind of mechanism to capture the virus, but the most useful is the electrostatic absorption. We can find around the fiber there are many positive static electricity, so that's why this is working. And we can have a look at how this metal-blown fabric is producing. This is the dial. The PP melt comes from this dial and belong to the fabric. And then come to this electric charging. Then this fabric have the static electricity. And after the cutting, then this fiber was widened. So this is the production of this metal-blown fabric. Okay, and for the production, this is a whole picture of how from the raw material to the metal-blown fabric. First, we need the metal-blown PP and mix with some electric mask batch. Then mix it together, and then the raw material coming into the extruder. In the extruder, the material is melted and come to the dial. This dial, we have some spinneret plate. In this place, the PP melt is blown by the hot air and come to extended to very thin fiber, and then come to the collector. In here, the fabric is formed. And by this electric charger, the fabric gets some static electricity. Then we get the final fabric. Okay, this is some introduction to the metal-blown fabric, how it's produced. And for this metal fabric, they have some important specification we need to check if whether it's okay or not. The first important is the filtration efficiency. So we need to stop the virus spread. So we need to have this BFE and the PFE. How to test the filtration efficiency? This is very simple. We have some salt particles from this machine, and these particles, like with some air, they can come into the test filter. In here, we put some fabric in this place. So we count the particle before this filter and after the filter. Then calculate how much particles was blocked or prevented from this fabric. So if the efficiency is high, it means they can prevent more particles. So if the PFE or BFE is higher, that means it's more effective. Second one is the resistance. When we wear a mask, if the resistance is much higher, then it's very difficult for us to breathe. So if the resistance is lower, it means we can breathe more freely. Second, we need to control the grammage of the metal balloon fabric. The grammage is the weight per square meter. Normally we use GSM. Here is we cut the fabric into some round pieces and then use the weight to get the value. And then, for example, if the grammage specification is 25 GSM, we have a 7% deviation. So we can find to check along the width, each place, what's the grammage, and to find the value. If some value is lower or higher, we need to make some correction to make it to make it stable and to decrease the GSM or increase the GSM. So this is grammage we need to control during the production. The third part is the mechanical properties. When we use this fabric, they also have some tensile strength and elongation. We use this tensile machine to test the property. We cut the sample by some scissor or knife. The length is 20 centimeter. The width is 5 centimeter. And our specification for this tensile strength is more than 10 Newton. Elongation is about 20%. If our test result is lower than this specification, that means the fabric is a little brittle and very easy to break. So this is when we get this fabric or what we should to test. Okay, on the third part, I would like to introduce how to make this metal balloon fabric and how to adjust the processing parameter. Because for this production, it's very simple. The principle is very simple. The PP melt come into the dial, and in the dial they have a one spinnerate plate. In this plate, they have thousands of small holes. The dimension of each hole is only 0.2 or 0.3 millimeter. So the PP melt comes from this hole and then extended to the fiber by the hot air. So if the MFI is higher, then it's very easy to flow and easy to extend it to finer fibers. So we choose the MFI is 1500 metal balloon PP to make this metal balloon fabric. Besides that, we need to control other properties such like ash content. If they have some ash content in metal balloon PP, it's very easy to block these small holes. So that means we need to stop. If the hole is blocked, we need to stop the production and to clean the spin rate plate and to clean all the holes. So this is very hard work. So when we choose the metal balloon PP, we need to follow this requirement. Then we can get some continuous production. And this metal balloon PP, if we want to find 1500 MFI, so normally the PP MFI is around 30. Some higher MFI is 100 for our injection. But for the metal balloon, we need to find higher. So how we do it to increase the MFI from 30 to 1500. So this is one point we should to find out the solution. And we can use the peroxide. We can add some peroxide in the PP, and then we come to the extruder. Then we can get some high MFI. So we find a different dosage of this peroxide. Then the MFI is increased. And finally, we get 0.4% of peroxide. Then we can get 1500 MFI. So this is how did we make this product. They have some reaction in the extruder. Then the PP molecular weight can decrease. Then we can get a higher MFI metal balloon fabric. Besides the metal balloon fabric, we need to add some electrical master batch. Why we need to add this one? Because for PP, the dielectric constant is very low. That means if we get the electric charger in this fiber, we cannot get a very much static electricity. So we need to add some nanoscale in organic filler. This filler, they have a very high dielectric constant, which means they can capture more static electricity, and they can use for a long time. So that's why we need to add this electric mass batch together with the metal balloon PP in this production. Here is some TDS of Kingfa material for the metal balloon PP and the electric master batch. Okay, we come to the processing. How can we make a good product of metal balloon fabric? First is we need to control the grammage. We want to make a 25 GSM metal balloon fabric. Then we need to find out the grammage is related to the frequency of meter pump, which means the output of the extruder. Second is the line speed. So the factor 1, this frequency of meter pump and the line speed can influence the grammage. But sometimes if we keep the frequency output and the line speed the same, sometimes the grammage can also change. So there have something different in this constant. This constant is related to our raw material, such like the MFI is changed from 1500 to 1200, then the grammage will also change. Another one is the mesh status on the filter and the dial. In the 0.4 and 0.5, we add some mesh to filter some impurity. If this mesh is stopped or blocked by some impurity, then the grammage will decrease. So this is about the grammage and some influence factors. If we don't have a, if we don't get the stable grammage, we need to check this 5 point. Then second is about the fiber. The most important is the fiber diameter. We want to get some diameter with 2 to 5 micron. This is very critical to our filtration, to the strength. So first we check the temperature, both of the melt temperature and the hot air temperature can influence the fiber diameter. We first check this on the left figure. This is the distance from the spinneret to the collector. When the PP melt come from the hose, the dimension is about 70 micron. But after the hot air extension, then it's decreased to 5 or 10 micron. So if the temperature is from 260 to 360, the final fiber diameter can decrease to about 5 micron. So if we want to get a good finer fiber, we need to increase the metal temperature. So this is the metal temperature influence. Second is the hot air. In this photo, we can have some SEM photo. If we increase 10 degree, the fiber diameter will come to about 2 to 4 micron. But if at a lower temperature, the fiber is about 5 or 6 or even larger. So this is, we need to control the temperature of our melt and the hot air. Also, our output can influence our fiber diameter. In this photo, is the fiber diameter related to output. First, we can take some example. If we want to make some 5 micron fiber, and we find this one, and in line 1, the output is 0.7 gram per hole per minute. If we have a die, the width is 1.7 meter. They have 2,000 holes. Then it means the output is 84 per hour. But if we want to make 2 micron, then the output is about 0.1 gram per hole per minute. And the output then is come to only 12 kg per hour. So by this figure, we can calculate how about our output and how about the final fiber micron we can get. So this is the output. If the output is higher, then the fiber will become, diameter will become bigger. And second is the hot air speed and pressure. In this figure, the line 2, the hot air speed is 200 meter per second. Line 1 is 500. So from line 1 to line 2 to line 1, the fiber will decrease. It means the higher hot air speed, the fiber diameter will decrease. Also is the pressure. If the hot air pressure increase, also the diameter will decrease. And then another factor is the die to collect distance. During the machine design, we have 2 kind of design. One design is horizontal. The die come here, and then the fiber is horizontal. Another one is vertical, the die from up to down, and here on the below is the collector. The horizontal design is mainly for some small machine, and for some big machine larger than 1.6 meter width, then we need to use the vertical design. During our production, the connector is far from this dial, but after the normal production, we need to choose to move this collector close to this fiber, to this dial. If we decrease the distance, that means the cooling is not enough, and the fabric can bonding is the fabric bonding each other is much better. Then the fabric can become hard and strong, and also the flying fiber will decrease. So this is we should to find a suitable DCD distance. After the fiber is come out, they will come to the electrical charging. So we have different way to get electrical charging. In most of design, we will choose the method, the D design. We can find in this, the fabric coming to the electrical charging. This bar, this steel bar is connected to the steel. And on the bar is a electrical wire. This wire is connected to some machine. They have a high voltage, and they can make some charging to this fabric. After charging, our PFE and the BFE will increase a lot from such like a PFE from 28 to 76. And if we add some electric mass batch, then the PFE can come to 96%. So this is the effect of electrical charging. Also, the distance of the electrical wire to the fabric is also critical to the filtration. This is different distance. If the distance is 10 centimeter, it's much close to the fabric, the filtration will become very high. If the distance is far, then the filtration is not good. So we should also to find a good distance of this electrical wire to the fabric. So in this slide, we summarize the factor which can influence the property of this metal balloon fabric. So for the filtration, all the property, all the parameter can influence the filtration. For the grammage also, some will influence. So if we have any problem about the filtration or grammage or mechanical property, we need to check all the factors and to find out which is the reason for this issue. Okay, we go to the last part. Is about some troubleshooting and case study. During our production, there will come some defect. The first one is the crystal point. In this SEM, we can find this this particle is about 28 microns, so it's very big. This is because during the metal balloon, the temperature of melt or hot air is too high, so it's not cooling enough, and then the melts come to the collector, so it stay in our fabric. So we should to against this reason, and we can have some solution to decrease this crystal point. Second is some flying fibers. Here is a dye from the dye tooth collector. Around the environmental, there's so many fiber come out. So this very so
Sorry for the inconvenience. We are checking it. Balaji sir, can you check with the Yark?